So hi, in today's lecture we are going to find the median of two sorted arrays. So in the question they will be giving us two arrays A and B. Okay, now we need to find the median. Okay, so the array will look like this. Now both the arrays are in the sorted order. Okay, and if we convert these two arrays into a single sorted array, it will look like this. Okay, now for this array, okay, if you need to find the median, we need to check what is the length. So here we can see that the length of an array is even. Now for finding the median of an array, we just need to see which element is the middle one. Okay, now here we can see that the mid values are 2, which is 3 and 4. So we need to find the middle element of 3 and 4. So how can we do this? Just take these two values 3 and 4 and divide it by 2. So 3 plus 4, okay, we need to divide it by 2. So this will be 3.5. So the median of these two array is 3.5. Okay, let's take one more example in which over here the length of both the arrays are not equal. Okay, so let's say this is 1, 3. Okay, now again if we convert these two arrays, okay, into a single sorted array, it will look like this. Okay, now again we can see that 1, 2, 3, 4, 5, 6. So here we can see that the length of an array is turning out to be even. So we need to consider the two middle elements, okay, and find the mid. So again the answer is turning out to be 3.5. Okay, now let's consider one more case. Okay, over here the array is empty. Okay, and this is the B array. Now if I convert this into a single sorted array, it will look like this. Now we can see that the length of this array is odd. Okay, so we can simply find the mid element, which is 3. Okay, so just return it. Okay, so I believe you got the question. Now how can we solve this question? So approach 1. Now if we have two arrays in a sorted order, the elements are, now what we can do, we can just take these two arrays and convert into the single sorted array by using the merge algorithm. So I believe you know what is merge algorithm. If you don't know, I will be referring that video, that lecture in my description, so you can just take a look. Now if I merge these two sorted array into a single sorted array, it will look like this. Okay, now here also it is turning out to be the even length array. Okay, so we need to find the mid values and after that the mid value and after that. Okay, so over here the mid value is 8. Okay, which is present at index 4, and also we need to consider the second value, okay, which is 9. Okay, and we need to find the mid value of 8 and 9. Now the question arises that after merging these two arrays into a single sorted array, how we can find the mid value? Okay, which is simple. Let's say that this is A, this is B, okay, and the new array is C. Okay, so find the mid value, mid index, by the way. So over here the starting index is 0, the ending index is 9. We have to just divide it by 2, so it will be 4. Okay, now we have to take this 4, so C of mid plus C of mid plus 1, and we need to divide it too. Okay, so this will be the median. I hope you got it. Now for merging these two arrays, okay, if the length is n and for this the length is m, for merging it will be taking order of n plus m time. Okay, and for doing this thing, for finding the median, it will be taking constant amount of time. Okay, so the time complexity for finding this median will be order of n plus m, and for space, okay, since we are actually creating one new array of size n plus m. Okay, the space will be order of n plus m. Okay, so I believe you got this. The thing is that I'm not coding it because I have already teached you that how to merge an merge and sorted array, okay, using the merge algorithm. Now this thing is very simple. Okay, we just need to find the mid, which can be happened using this, and after finding the mid we need to find c of mid plus c of mid plus 1, and we need to divide it by 2. That's it. So this will be our medium. Now what if the length is not even? So at that time we just need to return c of mid. That's it. So here, if the length is odd, so we don't need to do any kind of calculation, and this is for length is even. Okay, but in both the scenarios we need to find the mid value. Okay, now let's see the approach 2. Okay, now let's say that if we have an array which has a0, a1, a2, a3, ak, a k plus 1, and a n minus 1. Okay, let's see if we have this array which is in a sorted order. Now let's imagine that the length of this array is turning out to be even. Okay, so if the length of an array is turning out to be even, okay, to find the medium we need to consider two elements. Now let's imagine that these are the two elements. Okay, now as I told you previously, before that, okay, the length from this to this will be equal with this, right? So what I can do, I'll just divide this whole array into two sections. Okay, like this. Okay, now since we need to take these two values into consideration, now this value is the largest in this section, right? And this value is the smallest in this section, right? So please keep in mind that a of k is largest in first section and a of k plus 1 is smallest in second section. Okay, please keep in mind. Now let's move further. Okay, I'm taking the same example in which after combining these two arrays, the length of the resultant array is turning out to be even. Okay, now since the length is even, so obviously if I take a look for the first section, the length of the first section will be equal to the length of the second section, right? So here in this case, since the length is turning out to be 10 for the resultant array, for the first section the length is 5, for the second section the length is also 5. Okay, so let's try to pick some elements from array A. Okay, so case 1, let's try to pick only two elements. Okay, so if I pick two elements, which is 2 and 5, okay, so in the first section, okay, the total number should be 5, right? So obviously I have picked these two values, so from the B array I need to pick three values, right? So I am picking 3, 6 and 9. Okay, so this is done for the first section. Okay, now what about the second section? Okay, so I just need to pick the remaining elements. Now the remaining elements from array A is 8, 11 and 15, and from array B it is 9 and 17. Okay, so basically I'm doing some partitions. Okay, so with the help of the partition, what I will be doing, okay, I will be taking the largest from this and the smallest from this. Okay, and if I do the medium, if I need to find the median, okay, I just need to find the middle element. Okay, now if I'm picking this 9, okay, which is the largest in this first section, and 8, which is the smallest in this second section, okay, I can just find the median of that. Now here I can see that, okay, since if I sort this array, okay, and if I sort this array as well, okay, this 9 is turning out to be on the left hand side. That means the 9 is present on the first section, which should be wrong because 8 should be present here, right? So the partition that I have done is wrong, because this 9 and this 8, here 9 is turning out to be greater. Now let's try to pick 4 elements instead of 2. Okay, so I'm picking 4 elements, so it is 2, 5, 8 and 11. Okay, and since I'm picking 4 elements from array A, obviously I need to pick only one element from array B. Let's pick 3. Okay, now for section 2, I just need to pick the remaining element. So from array A, the remaining element is 15, right? And for array B, the remaining elements is 6, 9, 13 and 17, right? Okay, now let's see that whether we have done the right partition or not. Okay, so here if I see the 11 and 6, this is a wrong, right? 6 should be present on this and the 11 should be present over here, right? So I have done the wrong partition. So 11 is turning out to be greater than 6. Okay, now let's try to pick only 3 elements. Okay, so if I'm picking only 3 elements, it will be 2, 5, 8. Okay, and since I'm picking only 3 elements from array A, 2 elements I need to pick from array B, right? So let's pick 3 and 6. Now for the remaining section, the elements will be 11 and 15, and from array B it will be 9, 13 and 17. Okay, now if I take a look, the largest among this is 8 and the smallest among this is 9. So here the partition is right. Okay, so I just need to tick these 2 elements. I need to find the middle. Okay, and then we will be getting the median value. Now the question arises that how can we check whether we have done the right partition or not? How can we validate that? Okay, see, observing these 2 cases, okay, sometimes we are picking the maximum element, okay, the largest element from array A, okay, otherwise from array B, right? Also, if you want to pick the smallest element from this section, the second section, sometimes we are picking from array A, otherwise from array B, right? So we need to have 4 variables, which will be L1, L2, R1 and R2. Okay, now think about it. These elements are from array A and these elements are from array B. So obviously this element will be lesser than this as well. This element will be lesser than this, since they are coming from the sorted array. This is from A and this is from B. So we need to check these 2 elements, okay, and these 2 elements. We need to compare them. Okay, that means L1 should be lesser than R2, okay, and L2 should be lesser than R1. So here we can see that in this section L1, okay, it is lesser than R2, and also we can see that L2 is lesser than R1. Okay, if this is the case, then we can see that we have done the right partitions, and the partition is validate. Okay, so the conditions will be L1 should be lesser than equals to R2 and L2 should be lesser than equals to R1. Okay, now the question arises, what after that? How we can find the median? Now we know that since L1 and L2 are here, R1 and R2 over here, right? So among these two, we need to find the maximum, and among these two, we need to find the minimum. Okay, so for finding the median value, it will be max of L1 comma L2 plus minimum of R1 comma R2. Okay, and we need to divide it by 2. So then only we will be getting the median value. Okay, now I believe you got this. Now the question arises that since both the arrays are in the sorted order, okay, so can we apply the binary search in this? That means picking either 2 elements, 4 elements, 3 elements, 0 elements, n elements, so on. Okay, so let's see. Now, how many elements can we pick from the array A? In the lowest of low, we can pick 0 elements. So low will be 0. Now, what will be the value of high? At max, how many elements we can pick from the array A? See, from array A, we can pick all the elements. But what if this is the case? If the n plus m, it is turning out to be 12. Okay, so in the first section, there will be 6 elements, and in the second section, there should be 6 elements. Okay, and this n is turning out to be 7, and this m is turning out to be 5. That means the length of an array is 7. So my question is that since we are picking all the elements, that is 7, okay, from array A, is this the right way? The answer is no. That means you are taking 7 elements for first section. So for the next section, there are only 5 elements remaining. Okay, and obviously we need to have only 6 elements. So the high can be minimum of A of length, comma, n plus m whole divided by 2. Okay, so I believe you got this. Low can be this and high can be this. So let's try to dry run on this example. Okay, low will be 0, high will be minimum of length of A, which is 5, and n plus m whole divided by 2, which is also turning out to be 5. So high is 5. And what will be the mid? Okay, here in this case, the mid is turning out to be 2. It means that we can take 2 elements from array 1. That means the array A. So we are actually creating the partition. Now, when we create a partition like this, so 2 elements from array A and 3 elements from array B. Okay, here it will be 8, 11, 15, and from array B it will be 13 and 17. Now we can see that this is not the right partition, right? Because 9 is turning out to be greater than 8, right? So here we can see that L2 is greater than R1. If that's the case, what does it mean? That we have taken only 2 elements. Due to that reason, from the array B, 3 elements were present. What if we have taken some more elements from array A? So this 9 would have not come here. Okay, so we need to pick more elements from array A. Okay, if we need to pick more elements from array A, we need to increase our size. Okay, so we need to have low is equals to mid plus 1. Okay, if I do that, so low will be 3, high will be 5. 3 plus 5 whole divided by 2 will be coming out to be 4. Now let's see that what if we pick 4 elements from array A. So this will be 2, 5, 8, 11, and from array B we just need to pick one element. Okay, that is 3. Now the remaining element from array A is only 15. Okay, and from array B it will be 6, 9, 13, and 17. Now if you take a look about L1, L2, R1, R2, okay, we can see that L1 is greater than R2. Okay, L1 is coming out to be greater than R2. If that's the case, see, this 11 should be present on this section, right? On the second section. That means we need to reduce our picking. Okay, if we need to reduce our picking, that means we need to take our high and put it mid minus 1. So high will be mid minus 1. Okay, if I do this, then 3 will be as it is and high will be 3. The mid will be also 3. Okay, now we just need to take 3 elements. So it will be 2, 5, 8. Since we are taking 3 elements from A, we need to take 2 elements from array B, which is 3 and 6. Now we need, for the second section, we need to take the remaining elements from array, which is 11, 15, and from array B, it will be 9, 13, and 17. Now we need to check. Now here we can see that L1 is lesser than R2 and L2 is lesser than R1. Okay, so here the condition satisfied. Now we need to take the maximum of these two and minimum of these two, and we need to divide it by 2. So here the maximum is 8 and here the minimum is 9. So we need to do the addition. 8 plus 9 whole divided by 2, which is turning out to be 8.5. Okay, so I believe you got this. Now let's try to code it. Now initially the low is 0, high will be minimum of A dot length comma n plus m whole divided by 2. So this can be the high. Now there should be a while loop in which low should be lesser than equals to high. Now the question arises that how can we do the partition? Okay, now here we can see that we need to find the mid. Now technically, what do you mean by mid over here? Mid is nothing but that we are doing the partition on array A. Okay, and I'll just simply rename it to partition A. It will be low plus high whole divided by 2. So this is nothing but a mid. Okay, now if this is a cut, if I'm making cut over here, okay, that means I'm taking 2 elements from array A. Now I need to take the remaining elements from array B. Okay, how can I do that? See, in the first section there should be 5 elements, and how we can find it? By doing n plus m whole divided by 2. Okay, so these are the elements in each section. Okay, in each section. Now if I'm taking these 2 elements from array A, I need to take the remaining elements from array B. Okay, so I need to have partition B, in which it will be n plus m whole divided by 2 minus the elements taken from array A, which is partition A. Okay, I believe that you got it, that how we are doing the partition in array B. Now after that we need to find the L1 and L2, R1 and R2. Now L1 will be nothing but if the partition A is turning out to be 0, that means no elements are taken from array A. At that time, what we have to do? At that time, the value of L1 will be minus infinity. Why minus infinity? Because we need to find the maximum from the first section. Okay, that's the reason it will be minus infinity. Otherwise it will be simply A of partition A minus 1. Why A minus 1? See, over here the partition A, that means mid is turning out to be 2. Okay, so the L1 will be 5. How 5? Because we will be doing 2 minus 1. Okay, that's the reason it will be pointing to this first index. Okay, so this will be L partition A minus 1. Now what about L2? It will, if again, if you are taking no elements from partition B, okay, here also it will be minus infinity. Otherwise B of partition B minus 1. I hope you got this. If you didn't, please try to dry run it by yourself as well. Okay, now let's find the R1. Now here, if we are taking all the elements from the array A, okay, so array A is if n, then the value of R1 will be plus infinity. Otherwise it will be A of partition A. Okay, and what about the R2? Similarly, if you are taking all the elements from array B, then the value of R2 will be infinity. Otherwise it will be B of partition B. Okay, now we got L1 R1, L2 R2. Okay, now we are going to check for the condition if L1 is lesser than equals to R2 and L2 is lesser than equals to R1. If that's the case, then we need to check if n plus m is turning out to be even. Okay, then we need to have two values, and how we can find it? Medium will be max of L1 comma L2 plus min of R1 comma R2 whole divided by 2. But what if the n plus m is not coming out to be even? So here in this case, we just need to have the max of L1 comma L2. That's it. Okay, please, again I'm saying that please try to dry run it by yourself as well. Okay, this will be the condition for validating the partition. Now if L1 is turning out to be greater than R2, then we need to go on the left hand side. So high will be partition A minus 1. Otherwise we need to go on the right hand side. So it will be low equals to partition A plus 1. And that's it, we are done. Now this problem is coming out to be a hard problem. Okay, so it's very hard to come up with this approach. That's the reason it's a little bit complicated. Now, so that's the reason I'm actually telling you to please dry run it by yourself as well. Okay, so at last we need to return median. Okay, now talking about the time complexity. here we can see that we are applying the binary search approach. Okay, so it will be order of log n, and since we didn't take any extra space, so the space complexity will be order of 1. Okay, so that's it from my side. I'll see you in the next lecture. Till then, keep practicing.